Does your bus have a plate in the floor? Maybe factory installed, often added by mechanics in the equipment maintenance yard. This gives access to the fuel pump if there's one in the tank, and the sender unit for your fuel gauge, and a pickup tube. Without that, you would have to take off, can't reach in there, take off those bands down here and drop the fuel tank. And so that plate is giving access to the area right up here. Don't be surprised if you have to get in with a pick or a knife tip or something and clean out the slot on the screws. These have been sitting under the feet of 1,000 kids over the years. All right, there you go, and there is the fuel sender on the top of the tank. I'm going to clean this off down here and show you a better view of what that looks like. Of course, the reason I'm getting in here is because in this particular bus, the customer wants a diesel heater, and there are pickup tubes somewhere on the top of the tank. But I find that for adding in a separate pickup tube that's also easily accessible later, doing it in this floor access port or through it works pretty well. Now this is the fuel level sender, and it's got two connections on it. One is a ground, and then one is the center for the sender unit. And this is just measuring the resistance between these two, which changes as the float arm moves up and down. So you can pull that off and pull the ground off. Set those aside. Man, I got in here with a wire brush and cleaned a lot of the dirt off. You will see there's a good 3/4 of an inch of dirt piled up there. So I'll make sure I don't get any dirt in the tank. I'll do some more cleaning before I take this off. One thing, get out of the way, stay. All right. These are clocked. They are oriented in a certain direction because in here is a lever arm that floats up and down. It's got a float on it. And if it's turned the wrong way, it would hit the side of the tank and maybe not read accurately or at all. So you'll notice that these screws are not evenly spaced. And maybe because I'm old, I find that I fight with these things all the time. Okay, which way was it? So I'm just going to mark this with a little bit of a paint marker. So when I go to put this back in, it's just really simple for me to figure out that that's the way this is supposed to be oriented. So let me take the screws out and then clean this up a little bit more. I've taken out the screws. They're machine screws. These are actually those little type F. So see, it's got that little slot in the end. It's a thread cutting screw. And that kind of screw comes in handy in other places as well where you can't use a regular like sheet metal screw. If you got to go through something a little bit thicker, if you drill the hole to the appropriate size, these screws will actually cut threads in. So anyway, lift this out. And then once you get up here, you see the metal rod and the float. So you got to do a little bit of a dance to get that out. And now I want to check the orientation because I want to make sure that this, oh, that was stupid. Like trying to move the arm with the camera holding, or the hand holding the camera. Anyway, you'll see that this arm moves up and down, and really all it's doing, it's kind of cool if you haven't seen one of these, there's a little wiper in there. And as it does that, it's going through really just a longer and longer wire path, which increases the resistance or changes the resistance. So you can see down here, the pixies, the electricity, go through that wire down this trace, which is that little bar, I guess, on the side of the circuit board there, down to the bottom. So when the float is down, that wiper is really connected almost directly to this wire. And as the float moves up, that wiper moves farther and farther up the little curved path, and it's going through more and more little lengths of the wire, which is really a trace on that circuit board, and that changes the resistance. It's a longer wire path through tiny little connections. So anyway, that's how it works, and it's kind of cool. But back to the point, I want to make sure that when I put in the pickup tube, there, get the angle right. I'm still new at this, so here I am, I'm looking down at what I'm doing instead of watching the phone. I'm not used to living life looking through a phone screen. So back to what I was saying, when I install the pickup tube, I want to make sure that I put it in a place where it will not interfere with the free movement of the float arm there. So that's another reason I clock this and mark it. So I can put the pickup tube here or over here or on this side, but I think right here would be a good spot for it. And so I will do that here. You can make your own pickup tube, but in this particular case, I'm doing this for customer, and so I buy pre-made setups. They're pretty well made, and that way they just look a little more professional. They've got a nice fitting on the end for the 1/4-inch tube that you would use for a diesel heater. And they come folded. We will straighten this out. And then I need to put that through. I hope if I turn that on. Put that through a hole I have to drill in the top of the tank. When I drill that hole, I want to make sure I don't get any metal shavings into the tank. I'll show you how I do that and how I feed this through without dropping it into the tank. If you've done that once, you don't want to do it again. So anyway, I need to drill a hole that's basically 3/4 of an inch. And that's the next thing. I brought Ruby out so she can video this because this will take 2 hands. So the first thing I want to do is put in something just to keep any shavings from falling into the mouth. So I'm going to use a little bit of the aluminum tape and just stick this on here temporarily. Ruby, will you? Yeah. This is just a piece of scrap. Now, there are a couple different options. I could use this bit, which is a 3/4 inch regular spiral bit. You'd have to drill a pilot hole first. The downside of these is they don't work very well in sheet metal. In thin steel, they'll tend to grab and then they'll want to either stop and jam or drive themselves through, and they also leave a triangular hole. You could use a step bit, but those tend to put out more shavings or create more shavings than I really like. So for something like this, I use a carbide tipped bit. These you can get in the electrical section, designed for cutting holes in electrical boxes and things like that. And then I want a way to catch the plug. These don't put a lot of shavings down below, which is really nice. If you're doing this yourself, you could tape a plastic cup or something to a coat hanger and stick it in there. But in this case, we do this enough. I just made a little thing out of some scrap sheet metal from a project once, and I have a couple magnets on here. Let me start that one over again. Because we do this enough, whenever I encounter a need, I try to make a tool. And so I made this once before just out of some bus skin sheet metal. It's just 18 gauge that I folded and did a little weld on the corner and have a couple magnets. So now I can hold this in here down below while I drill from above. I want to not drop that in the tank. Now I know I want the hole over here, so I'm kind of lined up like that. Ruby, are you ready?
I think so.
All right, there's the pilot hole. Just got a little pilot. There you go. Helping Ruby out. A little pilot bit in the center. You'll notice that it's creating shavings up top. It doesn't do much until it gets to the end.
Not the best sound.
Not the best sound. There's chattering. It's annoying. It's like listening to your dad, huh?
No. Oh.
All right. So I am through. And now I've caught. Oh, we're getting a call. Now I've caught the plug, and all the little bits are stuck to the magnet in here. So now I'm going to plug that hole just temporarily and then clean up all the shavings around there so I don't drop any of those down in the hole. And then we can install the pickup tube. I straightened out the pickup tube, and now I need to cut it to length. These generic sort of universal pickup tubes just come long. So I run that down. Now that's the bottom of the tank. I could have run a tape measure down there, but I don't want to get my tape measure all oily. So I need to mark here. Let me do that. I marked that. Roll it. I did mark it. There. I marked it. Obviously, I don't want to cut it there. I'm just using that as a measure. So basically, I've got 13 inches from the top of the tank to the bottom of the tank. But I don't want to be able to drain the tank all the way down. If I'm out boondocking somewhere, or if this customer is, I want them to have diesel heat, but not so much diesel heat or for so long that they get stuck and run their tank dry, and now they die out in the wilderness in the winter because they couldn't drive off. So I want this actually a couple inches shorter. In fact, in this case, I may make it 3 inches shorter. So I'm going to measure this pickup tube 10 inches down from the top. Wow, will you look at that? That was not planned. So 10 inches from the top is just about at that mark. So I'll cut the tube off just about a 1/4 inch below that mark. Be right back. So I need to now feed this through the hole down there. In some of these, like I could drill a larger hole and sort of fit this through at an angle, but I think that gives the potential for too much play. These buses bounce around. You ever want to take it off road or even down our washboardy road, you'll have a bit of vibration. So I like to make the hole pretty much sized appropriately for this nut here. Anyway, I always tie a string or little chain or something to the pickup tube. Now I feed it through, and you want to make sure that your string is long enough. You don't want to drop this down in the tank and then try to feed it through, because if you slip, you lose it. So I always make the string long enough that I can feed it through first, have this end in my hand securely. Then when I drop this down in there, I'll pull it back up and put the nut on and the washer and everything. Make sure you've got everything at hand, otherwise you're stuck here holding it, calling for help. So now I've got this. I don't normally do this one-handed, but I'm just trying to do it for the video. And now I've got it securely, and I can put the nut and the washer on. I'll add a little note. You'll notice I've got the washer and the rubber grommet on there, the rubber grommet that seals it and the washer against which the nut will clamp everything together. I've still got the string on. That's because I'm holding the string under my knee. I worked in wind energy for years, and I learned to always maintain a point of contact. You always have, before you disconnect one means of attachment, you make sure you clip on with the other. And the same thing applies with your tools, because if you drop a tool, then of course somebody could get hurt down below. That was a hazard. But then you also had the bonus climb, and the bonus climb was if you forgot a tool or dropped a tool. So you didn't ever want to do that. So now I can run the nut on there. And once I get the nut threaded on, then I could safely take this safety string off. Now that I have this on there, it's not quite tight yet, but before I do too much work, I want to make sure I put everything back. Should have marked the washer too. See, I learned something every single time. Should have marked the washer so I can see those don't line up. Note to self, next time mark the washer, the gasket as well. Is that right? Nope. 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 All right, we have a winner. All right, now I can put those screws back in, reattach the fuel level sender wires, and then tighten this up. This is tight. The last step is to reattach the wires for the fuel level sending unit. That's the center post one, and the ground, you can't really mix them up. And then I'll put the cover back on, and this is ready for the customer then to use to attach their heater. Let me add a tool note. Most little crescent wrenches like this that I like for getting into small, difficult to access spaces wouldn't go wide enough for a nut that big. These little, what is that, DeWalt? This little DeWalt wrench is just pretty awesome. It's tiny, but look how much wider the jaw's open than any other small crescent wrench I've got. So this little DeWalt gets in here just fine on that large nut. In fact, I have to snug it down a little bit. Recommend those for tight places.